Good morning, dear friends. The last class we have learned about self-inductance of the stator as well as self-inductance of the rotor for the non-salient pole machine. So the air gap is uniform. Therefore, we end up with this equation where there is no symptom of variation in the rotor inductance. So that it is independent on the rotor inductance, stator inductance as well as rotor inductance. So in this lecture, we are going to learn about the mutual inductance of mutual inductance of salient pole non-salient pole machine. Already we know that the mutual inductance will vary with respect to theta, so that when the rotor angle is zero, mutual inductance is maximum. Then mutual inductance is zero for rotor angle is 90 degree. Then mutual inductance is negative maximum for rotor angle is pi. That means 180 degree. So like that we have learned many things. So this time we are going to derive the equation for mutual inductance of non-salient pole electrical machine or rotor. For that, let me share my white screen. See here, this is the stator, and stator have current is entering here and the current is leaving here. Therefore, reference rotor axis, stator axis will be like this direction. This is the stator axis. Then similarly, rotor is like this. So we can have, this is the reference of this is the stator axis. This is the reference of this stator axis as well as the angle at which we are starting this analysis, alpha equal to 0. Then this is the rotor reference axis. So in this rotor reference axis also, current is entering here and the current is leaving here. Therefore, magnetic flux density will be maximum in this place. Therefore, this angle I will call it as theta. This angle is, I will call it as theta. So this is 0, then this is pi. So now we have to write this first as like the previous. Normally, if you want to know this inductance, self-inductance, how we have found out self-inductance? Flux linkages of the stator. Self-inductance of the stator is nothing but flux linkages of the stator divided by current flowing through the stator. Similarly, flux linkages of the rotor we have written. Inductance of the rotor also, flux linkages of the rotor divided by current which is flowing through the rotor. So then for understanding flux linkage, we have derived flux linkage is nothing but number of turns. For example, stator means number of turns in the total flux. So how we will find out flux? By using the relation, flux is nothing but B in the area. Air gap flux density in the area. How we will find out B? BG is nothing but mu naught in the magnetic field intensity. How we will find out this HC? HC is by using Ampere's circuit law. So it's like that. We are coming now reverse from here. What is the finally? First we will write Ampere's circuit law. So either for mutual inductance, what we will do? Mutual inductance is nothing but we have to find the flux linkages of the stator by exciting rotor, or we have to find flux linkages of the rotor divided by exciting the stator current. So this is the way we have to find out the mutual inductance. Now in this case, we are exciting the rotor and we are finding the mutual inductance between stator and rotor. So now this is the current is leaving from here. Therefore, magnetic flux direction will be like this. Magnetic flux direction will be like this. Current is leaving, so the direction is anti-clockwise direction. So this is the air gap length. Already I have explained this. Air gap length is LG. Returning path is LG. So how we will write Ampere's circuit law? What is meant by Ampere's circuit law? Line integral of H vector, Hg vector dot dl is equal to number of turns in the rotor in the current flowing through the rotor. So now how we will write line integral of this closed path? Line integral, let me take this path into that Hg into air gap length plus the return path Hg into air gap length, that is nothing but number of turns nr into ir. So from that Hg is equal to nr ir divided by 2 Lg. Hg is equal to nr ir divided by 2 Lg. Then we have to find the flux. Then Hg we know. So then we have to find out the flux density of the air gap. So flux density is nothing but dg is equal to mu naught into Hg. Therefore mu naught nr mu naught then nr into IR divided by 2L. This is the flux density in this magnetic field due to by exciting the rotor. Then we have to find out the total flux density. This total flux phi T is nothing but we are now going find. We have completed this Ampere circuit law. Then we have found out flux density. Then we have to find out flux. Flux is nothing but Pg into area. So this is the cylindrical, rotor is a cylindrical, axial length also we have to take it. Accordingly, we have to write already this is a cylindrical surface. So axial, this is a cylindrical surface. So we have to take this axial length. Axial length is nothing but L, and the radius also we have to take, radius is R. Then another one that how much the distribution of flux density is important. So here the magnetic flux distribution of flux density will be, I will explain first after deriving it. Bg is nothing but mu naught into nr ir divided by 2Lg into area. How we will find out area? Radius into length. In already we know in previous case for magnetic flux finding this magnetic flux we have taken this region from 0 to pi. So how I have written pi minus 0. But in this case rotor is shifted. This if this angle is theta, automatically this angle is theta. So the rotor reference will start from here. So you no need to worry about this minus this theta minus theta pi minus theta. Then already this is in negative side. This is will be negative side. So this portion will be omitted. So we have only this portion only. So that let me draw the waveform like this. So magnetic flux density. This is alpha. Then we can take this is pi. Then we can take this is 2 pi. Assume this is our theta r. This is nothing but pi plus theta. So now till this, see if you start from alpha till here, rotor flux will be negative. Rotor flux will be negative. In this point, rotor flux will be 0. So that's 0. Till this, it will be negative. Then rotor flux density will be positive. Then till this pi plus theta, rotor pi plus theta, magnetic flux density will be positive. Magnetic flux density will be positive. Then it will come down and it is going to negative. So this magnitude is nothing but magnetic flux density. This magnitude is nothing but mu naught nr ir divided by 2L. So we are interested only this region. How we will find out this region? Pi minus theta minus, this is the region where it will be start from pi minus theta. So how we will write now this area? We will write it as mu naught nr ir divided by 2Lg. Then area how we will write? Radius into length. Then pi minus theta. Then in this portion, what happened? This is negative. This is negative side. So we have to subtract. This is only we are interested this region. So how we will write now? Minus mu naught NR IR divided by 2 LG RL. What is the portion in the theta? So this region is minus. So that minus mu naught NR IR divided by 2 LG into RL into theta. So we can have the phi T. Total flux is nothing but we have mu naught NR IR divided by 2 LG into R into L into pi minus 2 theta. Pi minus 2 theta. So that flux linkages of the stator is nothing but number of turns in the stator in the total flux linkage. So we have mu naught NS NR IR divided by 2 LG into R into L pi minus 2 theta R. Pi minus 2 theta R. Now we have to find out mutual inductance between the stator and the rotor, flux linkages in the stator divided by current which is flowing through the rotor. So this IR will cancel. So we end up with this equation mu naught NS NR divided by 2 LG into R into L pi minus 2 theta R. So now if you substitute theta R equal to 0, automatically we have MSR equal to mu naught NS NR R into L pi divided by 2 LG. Similarly, theta R equal to pi by 2, MSR equal to 0. Then theta R equal to pi, MSR equal to minus value. Therefore, this mutual inductance is varies with respect to rotor angle. The mutual inductance is varies with respect to rotor angle. So if you draw the curve of this mutual inductance with respect to theta, already we have drawn, I think this is mutual inductance. Here theta is 0 maximum, then minimum. Here it will be pi by 2. Then this is negative maximum pi, then 2 pi by 3, then positive maximum at 2 pi. So this is the wave shape of entire mutual inductance with respect to rotor. So then with this we can conclude today's lecture of the mutual inductance. So even one more thing I want to share to you with this. In this mutual inductance, you can see this case. If this theta R is aligned with this axis, stator reference axis, mutual inductance is maximum. All the windings are aligned together. As long as theta R is increasing till 90, this derivation itself you can see from here. This mutual inductance is in terms of cos theta. So that whenever this angle theta is shifted to 90 degree, automatically mutual inductance will be 0. Then again, whenever it is theta is equal to pi, a mutual inductance will be minus of the maximum value. So that I hope it is understandable that how that one can understand the mutual inductance with respect to the rotor angle. So in this next lecture we can learn about that salient pole machine, what is the stator inductance, what is the rotor inductance, and the mutual inductance between stator and rotor. So this non-salient pole machine, rotor and stator, is normally applicable for induction machine, and salient pole rotor, it is one can analyze for synchronous machine. I hope it is understandable. If you have any doubts, you can comment on, you can use the comment box and give me the feedback, and we can discuss further, and any corrections also you can let me know. Wish you all the best. Thank you.